You press a light switch, the room floods with light, instantaneous, no delay, no waiting, and somewhere in the back of your mind, you remember what they told you in school: electrons race through the wire, carrying energy from the source to the bulb. Neat, clean, simple. Completely wrong. What's actually happening when that light turns on would have blown your mind in physics class. And the reason no one told you the truth isn't because it's too complicated. It's because the real answer forces you to rethink everything you think you understand about energy, matter, and the invisible forces holding the modern world together. Richard Feynman spent decades screaming this truth into the void. Most people still haven't heard it. Let's fix that. Here's the version of electricity you probably learned. A battery sits at one end of a circuit. Electrons, tiny negatively charged particles, pour out of the negative terminal, race through a copper wire, pass through a light bulb, and return to the positive terminal. The motion of those electrons is the electricity. Their movement is the energy. Simple cause and effect. Electrons move, bulb glows. It's a clean story. It's also built on a foundation that doesn't hold up the moment you start asking hard questions. Question 1. How fast do electrons actually move through a wire? About 1 millimeter per second. Let that number sink in. 1 millimeter per second. A garden snail moves 30 times faster. At that rate, an electron starting at your wall socket would take years to reach a light bulb just across the room. Yet the moment you flip that switch, the light responds instantly. Not after years, not after hours, not even after a single second. Instantly. So what's traveling fast enough to make that happen? It's not the electron. Something else is doing the work. And understanding what that something is, that's where the real physics begins. Richard Feynman, Nobel Prize-winning physicist, bongo drummer, safecracker, and arguably the greatest physics teacher who ever lived, was obsessed with a concept most people never encounter outside of graduate-level coursework: the Poynting vector. Don't let the name intimidate you. The idea is devastatingly simple once you see it. When current flows through a wire, two fields appear around that wire simultaneously. The first is an electric field generated by the voltage difference between the two ends of the circuit. The second is a magnetic field generated by the moving charges inside the wire. These two fields exist not inside the copper, they exist in the space surrounding the wire, in the air, in what we casually call empty space. Now here's where Feynman's insight cuts through decades of bad teaching. When you calculate the direction that energy is actually flowing using the mathematics James Clerk Maxwell worked out in the 1860s, the energy doesn't flow along the wire, it flows perpendicular to both fields, which means it flows inward through the surrounding space toward the wire and toward any device connected to the circuit. The copper isn't carrying the energy, the space around the copper is. The wire is a guide, a channel, a boundary condition that shapes and directs an electromagnetic field, doing all the actual work in the invisible region surrounding it. Here's a thought experiment that makes this impossible to dismiss. Imagine a battery on Earth. You run one wire from its terminal all the way to the moon, 384,000 kilometers of copper stretched across the vacuum of space. You run a second wire back. Somewhere in the middle of this absurd circuit, floating 192,000 kilometers from Earth, you place a light bulb, then you close the switch. If electrons carry the energy, if the signal travels through the wire, then even at the speed of light, you'd wait over a second for anything to happen at the bulb. And electrons don't move anywhere near the speed of light. You'd be waiting years. But that's not what happens. The moment the switch closes, an electromagnetic disturbance propagates outward from the circuit, not through the wire, but through the surrounding space. That disturbance travels at the speed of light. It reaches the bulb in a fraction of a second. The bulb glows, not because electrons arrived, but because an electromagnetic field did. In 2021, physicist Derek Muller demonstrated a version of this exact phenomenon. Using a 1-meter loop of wire with a bulb positioned a meter away from the power source, he showed that the bulb responded in approximately 3 nanoseconds, the time light takes to cross 1 meter through open air. The signal didn't travel hundreds of meters through the wire. It crossed 1 meter through space. The field did it, not the copper. This is the question that naturally follows, and the answer is both humbling and beautiful. The electrons in a wire are doing something, just not what you were told. They're oscillating, drifting slowly in one direction, then another, moving in response to the field rather than generating it. Think of them less like water flowing through a pipe and more like a crowd of people swaying in response to music. The music, the field, is the thing that matters. The crowd responds to it. The electrons serve as the medium through which the electromagnetic field interacts with the physical components of a circuit. When that field reaches a light bulb's filament, it drives electrons in the filament to move. Those electrons collide with the tungsten atoms. The collisions generate heat. The filament reaches thousands of degrees. It glows. The energy came from the field. The electrons were the mechanism by which the field deposited that energy into matter. This distinction isn't academic. It's the reason the entire infrastructure of modern technology makes sense. Once you truly absorb the idea that electromagnetic fields carry energy through space, not through wires, technology stops looking like a collection of separate miracles and starts looking like one unified phenomenon with different faces. Radio. A transmitter forces electrons to oscillate up and down an antenna at a specific frequency. Those oscillating electrons generate a changing electromagnetic field. That field ripples outward through space at the speed of light. Hundreds of miles away, it reaches another antenna, causes electrons there to oscillate at the same frequency, and your receiver detects the pattern as information. No electrons traveled from the station to your radio. The field did. It was always the field. Wi-Fi. Your router isn't shooting electrons through the air to your laptop. It's generating oscillating electromagnetic fields at 2.4 or 5 gigahertz that propagate through walls, through furniture, through your body to the antenna in your device. Information rides the field, always has, wireless charging. When you set your phone on a charging pad, the pad generates a rapidly oscillating magnetic field. That field induces a corresponding current in a coil inside your phone. Energy crosses the gap between the pad and your phone, not through any physical connection, visible light. Here's the one that tends to make people stop and stare. The light entering your eyes right now is an electromagnetic wave, the exact same type of phenomenon as the electricity in your wall, just oscillating at a vastly higher frequency. Radio waves cycle tens of millions of times per second. Visible light cycles hundreds of trillions of times per second. But structurally, physically, they are the same thing. Electromagnetic fields propagating through space. The power line running past your house operates at 60 hertz. Visible light operates at roughly 500 trillion hertz. The gap between them is enormous in frequency, but the underlying physics is identical. Feynman loved making people sit with that fact. The light you see and the electricity powering your home are expressions of the same phenomenon. The electromagnetic field, just vibrating at different rates. Classical physics describes the electromagnetic field as a property of space itself, a region where electric and magnetic forces can be detected and measured. Disturbances in that field propagate outward as waves. That's Maxwell's framework, and it's extraordinarily powerful. But quantum mechanics goes further, and this is where Feynman's own Nobel-winning work enters the picture. In quantum electrodynamics, QED, the electromagnetic field is understood as made up of particles, photons. When two electrons repel each other, they're exchanging virtual photons. The force between them is carried by these quantum messengers. Every electromagnetic interaction, every push, every pull, every transfer of energy is at the quantum level an exchange of photons. This means that when energy flows from your battery to your light bulb through the electromagnetic field, photons are being created, traveling through space and being absorbed. What looks like a continuous field is, at the quantum level, a torrent of discrete particles, virtual, fleeting, unobservable, directly but absolutely real in their effects. And even more strangely, the empty space around your wire isn't truly empty. Quantum mechanics tells us that vacuum is seething with virtual particle pairs constantly blinking in and out of existence. The electromagnetic field is a structure imposed on this quantum foam. When you close a switch, you're not just pushing electrons, you're disturbing the quantum vacuum, sending ripples through a fabric woven from virtual particles, initiating a cascade of photon exchanges that carry energy across space at the speed of light. This is not metaphor. This is the actual architecture of physical reality as best as we currently understand it. The simplified picture, electrons flowing through wires like water through pipes, is useful. It lets you calculate current and voltage and resistance without needing to understand Maxwell's equations. For basic circuit analysis, the electron flow model gives the right numerical answers even if the physical picture is wrong. But that simplification costs something. It makes radio seem like a completely different phenomenon from circuit electricity. It makes wireless charging seem like magic. It makes the connection between light and electromagnetism invisible. It fragments physics into a collection of unrelated facts instead of revealing the single unified truth beneath all of them. Feynman despised this fragmentation. He argued relentlessly that physics should be taught to reveal connections, not hide them. That a student who finishes introductory physics and doesn't see the deep unity between electricity, magnetism, light, and radio has been failed by their education. The electron flow model is a useful tool. It is not the truth. And mistaking a useful tool for the truth is one of the most common and consequential errors in how we understand the world. So let's go back to that light switch one final time and run through what's actually happening. Your hand pushes the switch, a circuit completes. Electrons in the wire begin drifting slowly, barely, about the speed a fungus grows. But simultaneously, an electromagnetic field springs into existence in the space surrounding the entire circuit. That field doesn't wait for electrons to travel anywhere. It propagates outward at close to the speed of light. The field reaches the filament of the light bulb almost instantaneously. It drives electrons in the filament into motion. Those electrons collide with tungsten atoms, heat builds, the filament glows, you see light. The copper wire shaped the field. It gave it direction and boundaries, but the energy, every joule of it traveled through the electromagnetic field, permeating the space around and between the wires. Not through the metal, through the space. Feynman wanted you to know this, not as a technicality, not as an asterisk in a textbook, but as the central truth from which everything else in electromagnetism flows. Because once you hold it clearly, the world reorganizes itself. Radio towers aren't sending electrons through the air. They're sculpting electromagnetic fields. Your phone screen isn't powered by tiny particles racing down a cord. It's powered by a field that happens to be guided by a cord. The sun isn't throwing particles at your skin. It's broadcasting electromagnetic waves across 150 million kilometers of empty space. It's all fields. It was always fields. Energy flowing through space. Guided sometimes, unguided other times, vibrating slowly in power lines, vibrating incomprehensibly fast in visible light, but always the same fundamental thing, the electromagnetic field, doing what it has always done, connecting everything in the universe across the void of space at the speed of light without apology. That's the truth. They didn't teach you. That's what Feynman was trying to say.